What is the correct dipole illustration for the CH bond? First of all, we can eliminate choice C and D because the dipole must point in the direction of the more electronegative atom, as that's where the electron density is skewing, so it should go to the left. And because the electronegativity difference between C and H is very tiny, the size of the dipole is also going to be very tiny. While a 0.4 electronegativity difference technically falls within the moderately polar region, it's at the cusp, and in practice, a CH bond is categorically a non-polar covalent bond. What's the partial charge of this carbon right here within the molecule? Is it slightly positive, slightly negative, or neutral? Whenever we talk about partial charge, we want to pinpoint the phenomenon that causes it, and that's electronegativity, the ability of an atom within a chemical bond to attract electrons to itself. Here are the values for each of the atoms within our molecule, the electronegativity values. And since the focus is on this particular carbon, we are only concerned with that carbon and the atoms directly attached to it. Therefore, we can ignore the hydrogen. Then we can take note of each atom's respective electronegativity and then compare these values in pairs per each bond. Each CC bond, by definition, has no electronegativity difference and thus no polarity. But the CO bond does. It has a dipole and the electronegativity difference is 1. With an electron dipole pointing away from the carbon to the oxygen, the polarity of charge is evident in the fact that the oxygen has a partial negative charge and the carbon has a slightly positive charge. What percent of bonds in our molecule are polar? The first thing that we can do is count up all the bonds, and we have 8. We count this as one bond, even though it's a double bond, in the context of polarity. Thus, we can eliminate choice C because mathematically speaking, there's no way that we can get a whole number to get 60%. There's no such thing as 4.8 bonds. We can also eliminate all the CC bonds because they're by definition nonpolar, and we only have 5 bonds left to choose from, so D is not going to be the right answer. Here are the electronegativity differences for each of the remaining bonds, and with a 1.0 difference in electronegativity for this, it's going to be polar. But for the 0.4 for the CH, it's going to be non-polar. So our answer is going to be one of the 8 or 12.5%.